Hi everyone, welcome back to the channel. Today we are diving into another exciting AI project which is detecting phishing emails with the help of BERT. So in this project I'm going to cover two parts. The one is the theory part. We are going to understand the background, the type of the problem, what problem is that, okay, and then I will explain you the coding part as well, where I will train the BERT model to detect these phishing emails from the network. So before moving to the architecture part, let's understand here that what is actually phishing emails. So how it affects the victims, employees or users. So what happens actually? Okay, let's start the understanding from by looking this diagram. So here you can see the attacker. Okay, so what the attacker does, the attacker prepares a deceptive phishing emails, okay, intending to trick the victim. Now after that, the attacker sends this phishing email to the employee. It can be employee, it can be user, it can be you. Okay, now what does the employee does? Okay, the employee opens the email and sees a message that look legitimate but contains a malicious link. Okay, and sorry for that, I need to go. Okay, now the link in the email leads to fake phishing website that looks like a trusted site. Like it can be login page, it can be any shopping, anything. Okay, where a victim can enter a sensitive information like login credentials or anything like that. Now, after adding the credentials there, those credentials that send the stolen data back to the attacker. Okay. Now, what did the attacker does? So, attacker has now the sensitive data of the employee. The attacker is now going to log in into the real website and steal the data. Can do the transactions. Can do anything with that one because now attacker has the real credentials of the user. So this is the whole process, how the attacker attacks the user. Okay, so the whole process is called the phishing emails. With the phishing emails, how the attacker attacks the employee. Okay, so in this project we are going to cover, as I told you, two parts. The one is the theory one, the other one is the code understanding. So let's move to the next slides. Yeah, so here it shows that what is the background of this problem. So this is a problem statement. So I'll give you the overview of that one. So phishing emails are become at this now, because we have AI at this moment, we have ChatGPT. So it's becoming very hard to detect due to AI generated content that mimics real messages. Okay, so in this project, we are going to build a BERT-based model to automatically identify phishing emails by analyzing their text, helping protect users from the scams and data and thieves. That's the overview of that one. So let's move to the architecture of the whole project. What we're going to cover in this whole project. Okay. That's the whole architecture of the project. So what I'm going to do in this project, I'm going to load the data set, okay, and after that I'm going to explore the data set, how it looks like, what are the statistics are there, repetition of words are there, top words in the phishing emails, what kind of words they use, URLs, links, and all those stuff I'm going to explore from the data set. Okay, now the next step is data processing. Of course, we need some kind of processing as well. Okay, for example, lowercasing, removing stop words, but we will explain the data processing, everything in detail in the coding part. So yeah, after that I split the data into 70% for training, 10% for validation, 20% for testing. You can change this number by yourself. These are not the static, these are not any proven number. You can change, you can do the experiment with this number as well. It totally depends up you. Okay, now now we have the data, different data here, chunks. Okay, now I have to do the tokenization of the data set because the BERT model takes as the BERT model has a input format. Okay, so we have to convert our data in the form of that input format which we can feed to our BERT model here. Let me open my mouse color here if I can see. No, what am I saying? So yeah, this one. This is much more better. What was stopping? Okay, this is much more better now. Okay, now we're gonna feed this one to that one. So what's gonna happen here is that we will be training the model, and with the passage of time, we will be also testing our model on the validation data as well. Okay, so this thing is going to happen in the model training, and after training the model, we will evaluate the model on the test data, which is 20%. Okay, we are gonna measure the accuracy, precision, recall, F1 score, and confusion matrix. If these parameters are not good, okay, if the accuracy is very low or these matrices are very low, what we're gonna do is that we're gonna come back again here, okay, and train the model again and again and again and again until we get the good accuracy and all these matrices. Fine. So when we will get the good matrices, this number, good accuracy and that stuff, okay, then we will save our model, okay, for future use, and after that we will deploy our model anywhere so that it can detect the phishing attacks from the network. So that's the whole architecture of the project, okay. Now what I'm gonna do is that now let's move to the data slides. So first we have to understand the data. What kind of data is that? Who has collected this data? Okay, what kind of columns are there? Because that's really important. So okay, this part is really important. Yeah, and how many attacks are there? How many records are there? Okay, so we have to understand this detail. Okay, and then we will move to the next part, the coding part. Now let's understand the data now. Okay, so I have picked the data from this link, which is the Kaggle data set. So let's copy this one. What happened to you? Okay, I'm not gonna pick the CSV. I'm going to pick the. Let's copy it. I just saved. Let's copy and paste it. Oh, I was going to see. I'm going to see. Okay, yeah, that's the account. Okay, I have picked the data from this Kaggle account, and the account is from Nasir Abdullah Alam. Okay, and he has put all the information here. Very good information. Everything is completed, and usability is 10%. The usability means that all the information regarding the data set has been given. Okay, and then let me zoom in more for you so that you can clearly see that. Okay, now so this talks about the data. Okay, that's the data set information given here. The dataset was compiled by researcher to study the phishing emails tactics. Okay, it combines emails from the variety of sources to create a comprehensive source of analysis. Okay, so these are the data sets they have gathered. The final data set, as the information is given here, 82,500 emails. Okay, 42,891 spams email. So the data set looks balanced to us. Okay, so this is very good data set, I can say, and the citation is here. So if you are going to use this data set in your publications or anywhere, you have to give the citations for these data sets. Okay, yeah. Now what kind of data I'm going to pick is that there are many files are here. So if you go to this first one, which is 67 MB, 45 MB, okay, many are there. So I'm going to pick the last one, which is related to my project, which is phishing email. So this data set is the size of 106 MB, .6 MB. Okay, so if I just press on then okay, what we can see here is that we have two columns here. The first one is text one, okay, emails. We just only need two columns. Yeah, The first one is, this is the email. Okay, that's the email. It can be anything. Yeah, I mean any email. There's a phishing or the normal email. Okay, and this column, the second, which name is label. This value says 0 and 1, so it has only two values. So it is annotated data set. 0 means a normal email, 1 means phishing email. Okay, attack or spam, you can say. So yeah, that's the data set we have. Okay, and the rest of the things we are going to see in the Jupyter notebook. So let's move to the coding part now. Okay, I'm using Anaconda for this project. So I'm using Anaconda, and I have made new environment which is Torch for myself, and I have installed all the libraries, which required libraries inside that Torch. You can use the Python virtual environment, or you can also use the Anaconda for yourself. Okay, if you don't know how to make the new environment, you can search on the YouTube. There are very good videos are there, or if you still can't understand, you can write in the comment box. Then I can make a new video for that one. Okay, so I have this folder, and let's move to the code which is this one, the phishing detections. Okay, and I have already opened that one. So this is my coding part. Okay, now let me zoom in more so that you can clearly see the code, then complete Jupyter notebook. Okay, that's the table of content what I'm going to cover in the whole project. So as I have already shown you the architecture. Okay, and that's the similar one, the table of contents. So what we're going to do is that we have Explorer EDA, we have data preprocessing, training splitting, tokenization, data preparation, and the training of we have to define the training parameters and then train the model, and after that evaluation, and then after that saving the models, okay, for the future use. This is all we're going to cover in that one. Okay, so for that, that's the overview. You can read it by yourself. Okay, or that's the background of the whole project. And also what we're gonna do is that this also says that we are going to cover the train the BERT for that one. Okay, now let's move to the coding part. Now it starts from here. So before implementing anything, doing any steps, first task is to make a virtual environment in Anaconda or in the Python. The second task is to install all these libraries inside that environment. You have to install these libraries. Okay, so I have already installed all the libraries. So we have the pandas, regression, torch. These are for the plotting the data set. So this is for the training, splitting the data, for training the model, BERT model, and this is for the evaluation of the model. So I have these libraries here. Okay, let me run this one. Okay, now I'm using Panda to load the data set. So I'm going to explain whole code each line by line, so don't worry about that one. Okay, so what I'm doing is that I have imported the Panda with PD, and I'm saying pd.read CSV. Okay, because my file is CSV, so I'm reading CSV file, and that's the name of my file, and I'm saying CSV, so it's going to load the CSV file and gonna save in the DF. Okay, and now I'm going to check how many records are there, how many records are in my this CSV file. So I'm going to check with the help of shape function. So it is going to give me the shape. If I just run it again, it's saying that you have 82,797 records in this file, and you have two columns. Okay, so this tells about the rows, this tells about the columns. If I just check, say if I df.head, head means just print the first 5 rows. Okay, I mean few rows. Okay, that's the sample of the data set, how it looks like. Okay, now you can see the 82,797, so you can see like that. Okay, if I just delete it, because now it has the 82,000 rows. What I'm going to do is that this is for myself. What I'm going to do is that I'm going to only select the 15,000 rows so that I can easily run these cells during recording of the video. Okay, because 82,000 rows, they need the high computational power. Okay, but I don't want the glitching. I don't want to hang my computer during the recording the video. That's why I'm just picking 15,000 rows for the explanation of that code. Okay, you can go for you don't need to, if you want to complete 82,000 rows, you don't need to run this cell, just delete it. Okay, it's gonna take 82,000 rows. I'm just picking 15,000 rows just for explanation. Okay, just for simplicity, I will say. Now I'm just picking 15,000 rows, okay, from the full data set. So I have the function, I have the data frame. My whole data set is saved here. I'm saying dot sample. Sample is a function where you can define the number of records you want from the big file. So I want 15,000. This is the seed number, random state 42. You can define a number, okay. And now dot reset index. So it's going to reset all the index from zero, because it's going to pick randomly, so it can pick from anywhere. So I'm saying just pick for first 15,000 records from anywhere randomly, and then reset all the index, okay, like starts from 0 till 15,000. Okay, now if I just do the head, print head, so it gives me the 15,000 records only. But now you can see one thing here. Let me zoom in more full. I can see that okay. Now you can see one thing here, that look at the label here. It says 1.0, 0.0, 0.0. It looks a floating number, not the integer. We just only want the 1010 here, because as you know that we have in the original file of this one, the phishing one, we have seen the only 0 1 were there in the on the kaggle. Okay, so we have to convert this number into 1010. Why this happens? Because you know, in whole file, if there is one floating number, okay, anywhere, then when you read it, this function then reads the label, that column, in the form of floating number, because you have somewhere one floating number. So that's why it happens actually. Okay, we will convert that into in the form of integers. Okay, now let's do the preprocessing. So preprocessing, now we're going to cover that part in the preprocessing. So now the question here is that if you look at the other projects, you do the comprehensive preprocessing, very in-depth preprocessing. It can be like removing URLs, special characters, punctuations, numbers, stop words, capital letters, stemming and lemmatization, HTMLs. You do all the preprocessing in any NLP project. But I'm not going to do that one. Okay, I'm just going to do only two preprocessing, removing nulls and lowercasing my English words, because BERT handles cases that lowercase helps traditional models. Okay, because we use the lowercase in all the NLP projects, so we have to do that. The question is why I'm not doing that. The question is why I'm not doing all this preprocessing in this project. Okay. The answer is that because in phishing email, the attacker use the fake URL links. Okay, it uses different special characters. Okay, it can use punctuation anywhere, numbers, because the email is fake. So that's why the attacker uses all these things, all these concepts, all these things to make the email fake. So if I will remove everything from my email, okay, at this moment in pre-processing, then my model is not going to learn the actual fake email, how it looks like. So it's not going to learn it, because after removing everything from my email at this moment, what's going to left behind then? Nothing, just a clean text. So no, because fake emails don't look like that. Okay, very clean. So fake emails, they have everything like that. Okay, so that's why I'm not removing anything like that. You can see all the justification next to that, each of that one. So let's read it. So it says that URLs are strong indicators of phishing, so we keep them as feature. Symbols like special characters are commonly used in phishing tactics and should be retained. Punctuation may be part of deceptive informating or URL, so we do not remove it. Okay, so that's the complete justification of each of them. So that's why I'm not doing the I'm not pre-processing that. I'm not removing that stuff from the email. Yeah, honestly. Now what I'm going to do is that I'm going to remove the null values, okay, and lowercasing. So for that one, I'm going to use the df.drop_na, and in place true means that just work in place true is equal to true means that just work on the original data. Okay, so it's going to pick the original df and remove the null values from there. Okay, now I have told you above that we have the values in the form of floating form. So what I'm going to do is that I'm saying the df, I have the label inside, which is my column name. I'm saying just convert that into in the form of integer. So it is going to convert that in the form of integer and update the label column again. Okay, now lowercasing, so I'm writing a small function for that one. What I'm going to say is that I'm defining a def function. I'm giving the name clean text. Inside that I'm taking the input as a text, so I'm returning, I have small function here which is text.lower. Okay, so what's going to happen is that from here I will say text. I'm taking my first column, which is text one. I'm dot applying. Okay, and inside that I'm giving the functions here. So what's going to happen, this apply function will take one email, okay, send it to the function, lowercase it, okay, lowercase it, return it, stored on that place, pick the second one, third one, fourth, fifth, and on so on, and it's going to pick everything. Okay, and then lowercase all the emails from the file. Okay, so I can run this one, and okay, now we have one more function which is df info. It gives the information of the whole data set. You can see we got 14,949 records are there. Indexes are the same till like around 15,000. We got two columns there, and the rest of the information about the columns are given, which are text, label, name. Data types are given, and the amount of the memory has been utilized by this data frame is also given here in the form of KB. So this is just information. You can understand it helps you to understand the data set. Another built-in function which is shape, which gives us the shape. If you want to see some top rows, okay, you can use the function head. It shows now you can see the email here, okay, and now you can see the labels are in the form of integers. So there's one more function. If I say tail, it shows the last 5 rows from the data set. So you can see from here last 5 rows, so you can see that here as well. Now we are going to explore the data with the help of graphs. Okay, before we were understanding the data from some matrices, from statistics. Now that is graphs time. So what we're going to do is that we are going to plot some graphs to understand many things like number of phishing emails, normal emails, what common words are there in the emails, number of special characters in each email. We are going to plot all those graphs. So let's explore the data now. So I'm using a very simple code of SNS library, which is Seaborn library. Okay, so what I'm doing here is that I'm plotting class distribution. Okay, so I have the code here, which is PLT from the matplotlib library, and I'm defining the size of the figure. So I'm saying put the width, which is 6, and height 4. You can change this size, it depends on your requirement. Okay, and I'm using a counter plot functions. Is the function of Seaborn library. What it does, it counts the number of occurrence of each unique value in the column. So it is going to count the labels, like how many phishing emails or normal emails are there. So it takes the data frame and the label the particular column, and then you can define the title here, and we can define the title, and then we can define the x-axis, y-axis. So x-axis I'm saying, okay, 0 means legitimate, okay, and 1 means the phishing, okay, so you can define as well that. And now y is the count, and now plt.show, which shows the whole graph. So now you can see whole graph here. You can see legitimate cases are around 7,000, and then phishing emails are like around 8,000. So total, that's the total, total both of them is the total record, okay. At here you can see the data set is quite balanced. It's not exactly balanced, but it is balanced. So it's a good thing, and it's good for training as well, and for evaluation the model is a really good parameter here. Now let's move to explore the number of special characters, okay, in each email. So for that, special character means these are the special characters I have defined here, okay. So what I'm going to do is that I'm writing a code here, okay. So what it does, so this is a box plot comparing the number of special characters used in legitimate versus phishing emails, okay. So we are going to compare that how often they use the special characters in the phishing emails, and also comparing with the normal emails as well. So here I'm saying data frame, pick the text from there, okay, text column, and dot apply the function, and lambda, I'm saying lambda x, okay, and I'm saying here, okay, it's doing this sum, but you can see I am not picking the alphanumeric characters from the text, and also the spaces. So because these two things are not the part of special characters, okay, alphanumeric one and the spaces. So that's why I'm leaving that stuff here. That's why I'm saying no. At the end, so when you run this code, it is going to give you the number. It's going to make the first is going to make the new column, okay, with respect to each email, and then it will give you the number that how many special characters are there in each email. So I'll plot that one, and I'll show you that one as well. Rest of the things are same. Defining the figure size, box plot. You have to give the labels inside that one, and y-axis is these are the labels, okay. We're giving the data. We are here defining the colors. You can define the colors. It's up to you. Depends what colors you like, okay. And rest of the things are x-axis, title, y-axis here. And because we are comparing two things, legitimate and phishing emails, so for that I'm using the grid, okay, so that I can show the comparison in within one graph. So you can see the graph here as well now. So in some of the emails, like around some of the emails, they have used around like this number of special characters, and in the phishing emails you can see like that, and in normal it goes till here. Yeah, so these are the x-axis, these are the labels. Here you can see the labels with the help of legend as well. Now let's plot the most common words they have used in the phishing email, okay, so that we can understand that what kind of words, what kind of special words they are using to grab the attention of the users. So for that, what I'm going to do is that I'm saying here, okay, I'm importing the library counter. I mean, from collection I'm importing the counter to count for the count. NLTK is another NLP library, okay. It's really good library. What I'm going to do is that I'm importing the stop words and downloading the data of stop words the NLTK has, okay, because I don't want to because I want to remove the stop words from during that filtrations, because stop words are everywhere. So what the stop words are, that means the they, is, and so I don't want those in my common word searching. So what I'm going to do is that I'm defining the stop words from the English language. Okay, now here in this line what I'm doing is that combining all phishing emails, join all text into one string, okay, converts to lowercase and split into words. So what's happening here is that if you start it from here, so this is main data frame. I'm saying inside this main data frame, pick the data frame, okay, labels, where label is equal to 1. So I'm only going to plot the most common words from the phishing emails, not from the normal emails. So just only phishing emails. Okay, so I'm saying if the label is equal to 1, pick the text from there. Okay, lowercase it, split it into in the form of words. Okay, so that's why I'm just selecting only label. Yeah, that's fine. Split into the words. Okay, and then now when it splits, so it gives you the word. Okay, so I'm going to join those words with the help of join function. Okay, and then storing here in the phishing words. Fine. After that, now I need to do the filtration, more filtration. Now I have the words, all of the words are there. Okay, but now I need to filter the stopping word from there and alpha. And I only need to pick the alphabetic words, the proper words from the email. So for that I am writing a loop here. So I'm saying for single word in phishing words. So we have so many words here. Okay, it's a combination of stop words. All the words are there inside. I'm picking one word. Okay, and because it's a loop, so I'm filtering. I'm doing the filtering. I'm saying if word dot is alpha. Okay, if the word is alphabetic, that's fine. And word is not in this stop word. If it is not in this stop word, then please store the word in the word dictionary, in the word list. Okay. So I'm doing the filtration here. I need to pick the alphabetic, and that word must not be a stop word. If it is a stop word, we don't need that word. Okay, just filter out. And I'm storing that word in a word dictionary, and then storing all those. In this way I'm checking each and every word here. So first word, second word, third word in the word from the phishing word. So in this way I'm checking each, and then I'm saving all the words here in the filtered word variable. Now the counter is going to count, okay, the frequency of each word, okay, and the most common word. So what we're going to do is that we are going to pick the top 20 words from that particular list, okay, and then we are going to plot on the screen. So unpack the 20 most common word count pairs into two separate lists, words and counts. So we will get the words here, we will get the counts of that one, because this variable contains both the information, words and counts, okay, and then rest of the information is same. We are just giving a plotting bar plot. Is take x-axis, y-axis, it takes the colors, and you give the title, x label, and then show it. That's the proper graph. Let me zoom out so you can easily read it. Now this is the graph. This is the graph. Now you can see that in phishing emails they have used AUG, the word most common. I think it's August. Email, top, companies, please, you can see the please word they have used a lot. Money, of course this is a phishing, so they are talking about the money as well. Phishing. So one, news, account, so they're talking about money, accounts, us, CNN, time, information, get, daily business, CNN, name, news. So these are the top 20 words. So if you can run like as much as you can. So if I go for like 30 and run it, I can see 30 words here as well. Cable, word made through in this way. Yeah. Now I'm going to plot the WordCloud to see those words. So you can see the word. Let me zoom out. WordCloud here. The more bigger the word is, means the more frequency of the word is from those emails. So you can see the network is there, top is there, daily is here, August is here, and all those words are here. Okay, the code is quite simple. You just need to pick the filtered words from the top and then it's going you just need to join them, okay, store in the form of text, and then inside the WordCloud you have to import that with the WordCloud, and you just give the width, height, color map, and then say dot generate, and inside that you give the text, okay, and generate, and then you just use the rest of the code as I have explained here above, and it generates the WordCloud for you. So now we have covered these three steps: loading the data set, data exploring, and data preprocessing. Now it's time to do the data splitting, okay, which is like training 70%, validation 10%, and testing 20%, and then we'll move to the next step, which is tokenization. So let's first do the splitting of the data, okay. So how I'm gonna do the splitting, so I have the code here for the splitting. Let me zoom in more for you. Okay, so for splitting I'm using the library train test split. I have already import this library by importing it here again, so that you can see that what library I'm using for that one. So I'm using this code here, this one, the train test split, okay. Inside that one I am using my main data frame text column, and I'm converting that in the form of list. Same, I'm using the other column, which is my label, and I'm converting it to the list. So here I'm giving the 20% test data, and rest of the data is you can say the train data. But further I need to split that 80% again, like 70% is training and 10% is the validation. So random is the random, okay. Stratify DF labels means that here that the distribution must be balanced between the test size and then training. So this technique helps us to avoid the imbalanced distribution of the labels from during the splitting. So this is really good technique actually. Once we get the here like 80 to 20%, now what we're going to do is that we are again going to split the 80% into 70% for training and 10% for the validation. So again I'm using this function. Inside that one I'm putting my 80% data, okay, which was the 80% here, like, okay. So and the labels are here, the 80%. So this function is going to split that into what I'm doing here is that I'm taking 12%. So if you just put 0.10, okay, this is going to take so 10%, okay, 10% of the data, but I'm taking 12%, okay. So 12% of the whole 80% I'm taking here as a test data, and rest of will go for the training data. And the same strategy I'm applying here for the balanced distribution of the classes, okay. Let's see the how our data looks like. So for example, if I pick validation here, see how it looks like. So you can see that our data is in the form of list now, okay. One email per list, this is second email, and so on. Fine, this is how our data looks like now at this moment. Well, we don't need that too much stuff here, okay. So this was the splitting of the data set, okay, and you can see that our data is in the form of list now. So the BERT model doesn't take the list as an input. It doesn't take the English word as an input. The model only understands the number. So we have to convert this list in the form of numbers, but the BERT has a specific format of input format, a specific format. So not only we have to convert the text data in the form of numbers, but also in that format which the BERT takes as an input. So for that, what we're going to do is that we're going to do the two steps. The first one is the tokenization. Okay, we're going to do the tokenization, and after getting the input from this tokenization, we will format that tokenization in the form of that particular BERT input format. Okay, so let's understand what is the tokenization actually. Uh, one, so let's move to the website of the tokenization. This one. This is the website, the official website of Hugging Face. Okay, and here there's a complete documentation of the tokenization, what is actually tokenization, and how it converts your raw text form in the form of tokens. Okay, so that's the whole process, that's the whole email. So for example, this is your email: hello, how are you today? Okay, the first step is normalization. So normalization happens here. You can see that it has converted all the uppercase into lowercase. It removes the extra spaces as well. It adds commas, or whatever the rules are defined in the normalization, it is going to apply on your raw text data. After that, it applies the pre-tokenization. Okay, so pre-tokenization, you can see you have the sentence here. Now it is going to convert your sentence in the form of tokens or small tokens. Hello is a one token, is a one word. How, and this in this way. Okay, it is it has converted in the form of tokens. Now in the next step is the model. So model is already a trained model on the raw text data. It knows it knows how the token look like, what's the meaning of that particular word. So what it is doing, look at that one, the rest of the things are okay. It knows that that's fine, but there's a problem with t day. Okay, so what it's going to do is that it's a t day, that's fine. It has put in a one token, and it is using the hash to hash in ay. So what it's saying that this token, let me bring my mouse again here. So it's saying here that this double hash is a part of this word. Okay, and now it divides the sentence in the form of these tokens. And after that, it does the processor. So what's the post processor? Post processor adds two more words in that sentence. So one is CLS, which represents the start of the sentence. Okay, and SEP, which represent the end of the sentence, or you can also call the separators between two sentences. If there are two sentences, it tells the model that this is separation between two sentences, and also represent the end of the sentence if there is no sentence at the end. Okay, so that's the overall what happens in the tokenization, and you can read all the documentation from here. They have the code here, you can pick the code from here. Okay, and the complete documentation is given there, and they're also talking about different techniques they apply within the tokenization. So yeah, so what I'm doing here is that they have the BERT based uncased tokenizer. The tokenizer is already trained on huge amount of the data. Okay, and it knows that how to convert our raw text in the form of tokens. So I'm taking that pre-trained token. Okay, I'm loading that one with the help of BERT tokenizer. Okay, there's a one function, this one, and I'm just giving the name of the model, and it downloads the big model for me. Here I have already downloaded. When you will run it, it will show you some download bars there. And then what I'm doing is that I have this tokenizer object here. So in that one, I'm giving my train text data. Okay, and tokenization, that's true, and padding is a true. Tokenization means that if your email is tokenization is for maintaining the same length of all the sentences, all the emails. Some emails can be like 500 characters and some can be 2000 characters, but models take the input of same length. So we are going to give the model a same length of the email. So if someone is 2000, it is going to authenticate that email into 500 characters, so that all email can be 500 characters. Padding means if for example, if one email is 200 characters, and but the total length we are giving to the model is 500, so it is going to add the zero padding from 200 to 300, 200 to 500, zero padding, to match the length of the sentence. I'm doing for the training text data and also the validation here, It gives us the trains encodings, validation encoding. So if I show you how it looks like, look at that one, how it looks like. If I just pick the 0, 0, and this is how it looks like. Now, this is important, that why we are doing that. And what are these things? Why there are so many numbers are there, and what is input IDs, what is attention mask? So this tokenizer takes your raw data like the email, okay, and gives you the output in the form of input IDs and attention mask. This is the format that the BERT model takes as an input. Input IDs, this is the input ID. You can see 10140, okay, and rest of these things from here till here are the padding which I have set the true. This is 0 padding. The length of the sentence was there. So that's the numerical representation of those tokens, a numerical representation of the sentence. Okay, this is first word, this is second, third, fourth, fifth, and so on. Okay. And the attention mask tells us that it tells the model that this is, you have to focus on this word, this word, this word, and these words, okay, till here. And where it starts the 0, because 0 is the padding, we are just matching the length of the sentence. It says you don't need to focus on there, because the rest of the part is just padding 0 number, that's not important. So this tells the model that's the important part of the sentence. Okay, we will go our input data in that format to the model train on that data. So that's the input format. Okay, if I read it more in depth, okay, so the thing is that at this moment I'm getting the input IDs, attention mask, but still it's not in that format. That's okay, the format is okay, but labels are missing as well. So this is just input text, okay, but labels are missing. So what I'm going to do is that I'm writing one function here. Okay, I'm writing one function here which is going to take the labels as well and going to convert those encodings in the format as well. So let's read some of the information here. Yeah, it's saying that this model is taking the encodings and going to give you the output in the form of input IDs, attention mask, which we have already seen, okay, and labels as well, but in the form of tensor. So you can see that this thing is in the form of list at this moment, but the BERT takes the input in the form of tensors. Okay, and I have put the rest of the information here. You can read it by yourself here. Now, what's happening here is that I have written a class which is the email dataset, and it is for formatting the train data, or any data, you can say, like train validation, but it is a formatting class. It's just taking train encodings, which we got from the above, and train labels, which we got during the splitting. Okay. Now we are giving these two things to the class, and we are just assigning here onto the self variables. So in this function, okay, it is taking the IDX, means the index of that email from the data, and it's saying here that for loop KV, okay, in self encoding item. So it is saying pick that email, okay, and its attention mask. Because the encodings are here, training encodings. So we have the inputs and attention mask, these two things. One is the here, second is this here. So I'm saying pick KV, okay, KV, okay, of that particular index, which it can be 0, 1, 3, and okay. Now it's saying V is picking that one, okay, and it is converting. Attention mask is okay, but it's just picking only the encoding IDs. Sorry. It's picking the input ID, so it's saying that convert that ID, okay, in the form of tensors, torch.tensors. So we are just extracting those attention mask and input IDs, these two stuff, okay, these two stuff we're just extracting, but on in this for loop we are converting the input IDs in the form of tensors, and then K is okay there, we don't need to convert that one. Okay, fine. and storing in the items. The same we are doing for the labels. We are picking the labels, okay, labels, which are labels are here, okay, of that particular index, and then converting in the form of tensors, and then storing here, and returning the items here. So this is for the returning the lengths of the labels as well. So you get the trained, complete, well prepared trained data set here. So what this data set contains? This data set contains input IDs in the form of tensors, attention mask, and labels trained. So the model will take this format and is going to train the model on that one. Okay. Now we have prepared the data set. Okay. If I go to the slide, we have prepared the data set. Now it's time to train the model. To train the model, we have to define some parameters. But the thing is that there are two ways to train the BERT model. One way is that if you train the BERT model from scratch, you can do it. Okay, that will be a new model. But here I'm not training from the scratch. I am fine-tuning this. Fine-tuning means that the Hugging Face library, the Hugging Face, the company, okay, they have already trained the BERT model on the huge amount of English dataset. So the model already knows 80 to 90% of this stuff about the English, and rest of the 5 to 10%, I'm just training that model on this specific phishing email dataset to okay on that dataset to work on this specific problem. So this is the complete explanation documentation of this model. But based is a base one. Base means a small model. Uncased means it doesn't differentiate between like the capital English. Here it is. The model is uncased. It doesn't make a difference between English and in English. So it means it's not case sensitive. Okay. That's the complete information is here. They say that the model is pre-trained on a large corpus of the English data in a self-supervised fashion. Okay, and it knows a lot of stuff. If you go down, there are different kinds of models as well. You can take it. So it says the one I'm using, which is base, is 110 million parameters. It's trained on 110 billion parameters. There's a largest one if you want, 340. And so on. There are different are there, and you can use that with the help of this code, and the rest of the information is given here. You can check it by yourself. So the thing is, I'm fine-tuning this model on the phishing email. If I simplify what is actually fine-tuning, let me search on the Google fine-tuning examples. If I just go to the images and I think this is more clear example if you can see. So what they're saying, this is, I have this. So the Hugging Face, they have done the training till the parrot. Okay, now they have complete parrot here. Okay, which is base LLM, base model. Okay. What I'm doing here, I'm picking that parrot, which is already a complete, you can say a complete BERT. I'm training this BERT, okay, with on my specific data, which is phishing email, okay, supervised fine-tuning, which I'm doing at this moment, okay. Now after training, that parrot will be more knowledgeable about that specific, which is phishing email. So the best thing is that I don't need to do this stuff. This is big stuff. I don't need to do that one. This, which is already there, I just need to pick that one, okay, and train it on specific problem. And now this is more efficient, more powerful model I have with some little effort. Yeah, that's the meaning of fine-tuning. The other way, if you want to train a model from the scratch, you need to do that stuff from here. You need to get that data, big data, and train the model on to make up first complete parrot, okay, and then do the stuff, rest of the stuff. Yeah, that's the example, okay, for them. I'm using BERT from sequence classification library, okay, and for the function pre-train, I'm picking the uncased and number of the labels which I'm using two labels, either 1 or 0, either is a normal email or is a phishing emails. I'm just using 2. Okay, so that's why I'm defining the labels here. This is evaluation metric. I will explain you later. It just it does the evaluation of the model on the test data, which is accuracy, F1 score, precision, recall. But I will explain you later. Now for training the model, we have to define some parameters first. So here we have one library. I have imported on the top of this notebook, and this is training arguments. It takes the parameters as an input. Okay, these are hyperparameters. You have to define it here, and you can do an experiment on these parameters. These are not these are not like good parameters. I can say, I mean, the expert parameters. You can change it by yourself. It depends on your experiment. So it says that training argument is a configuration class that defines how your model should be trained. You pass it key training parameters such as output, dir directory, where to save the model checkpoints, learning rate controls how fast the model learns, number of epochs, evaluation strategy, per train, batch size per CPU GPU device during training, and logging directory, and that's the rest of the information. It doesn't train the model, it's just taking the parameters that how to train the model. It only stores training settings that the trainer will use. There's one more function. That function is going to use these parameters to train the model. What I'm doing is that these are the evaluation matrices, storing the data. For me, the important, of course, the all parameters are important if they are here. But learning rate is important as well. Number of epochs, which is 5 at this moment for me, because I'm just teaching that stuff. But if you are going to train a model, you will do different experiment with these epochs. You can go for 30, 50, 100, 200 is up to you. Weight decays are there, optimizers is there, and yeah, rest of the information is there. You can see that by yourself. But these are the hyperparameters. Now there is one more. A training engine is there. So a trainer, this is one. What it does, trainer is a training engine provided by Hugging Face. It handles the full model training lifecycle. Specifically, what it does, it loads and train your model, handle batching, okay, shuffling and tokenization, train the model using PyTorch under the hood, evaluation the model, and using the setting whatever we have defined in training arguments, and it also search for GPU or CPU for the training. So what we are doing, this is trainer. Okay, inside the trainer I'm defining the model. The model is equal to model. This is my model which I have here, this guy. This is my model. Okay, I'm giving that I'm using this model. Okay, pre-train. Training arguments, these are my training arguments here. Okay, train data set we have above, validation data set we have above, tokenizer we are giving here what tokenizer we are using. Okay, data collector with padding, again we are going the tokenizer. Okay, and the compute matrix. Okay, so yeah, for the computation of the different parameters I'm giving the compute matrix, which is here. Okay, so what happens that during the training it gives the prediction to this metric. Okay, this metric extract the information, the label IDs, okay, and which is the labels, and the prediction from the models. Okay, and then with the help of formula precision, recall, F-score, support, we give the input parameters and we calculate the average, which is binary, and then we also calculate the accuracy with the help of accuracy formula, labels and prediction. And so these two functions, they calculate the precision, recall, F1 and accuracy, and return all the information back to the trainer here. Okay, so that we see the evaluation during the training with the help of this one. Now once we have defined that one, now it's time to train the model. These two things, they are taking the input things, and now training. So how are we going to train it? So we have a training the model. So training starts from here, trainer dot train. So this guy, it has a one function which is train. Okay, it is used to train the model. So if I read the explanation of that one, it says here, The trainer.train method is the command that starts the training process using the configuration and dataset you have defined with Hugging Face trainer classes. Okay, what it does, it loads the dataset, loads the model, batches, computes the loads, perform the backpropagation to update the model weights, evaluate the model in evaluation data. If the evaluation strategy is set to epochs, I have set to the epochs, means after each epoch it is going to evaluate the model. Okay, checkpoints are there for saving, and logs training matrix, which we are going to get on the validation data. That's the stuff it does internally, and what we get as an output is that after running the train on your training dataset, optionally validate each epoch and save to directory specified in the output directory. So it saves the checkpoints as well. So by pressing that one, we will start the training from here. So if I just run that one, let me run it. I need to let me run that stuff again. Yeah, the above cells were not I just run those above cells. Now it's going to train my model now. Okay, I have trained this model on my Google Colab account. So I just trained this model on 6 epochs, you can see here, and it took like 1 hour and 38 minutes. So it depends on the data set and then type of computation you use for training. So that took that time. Okay, if the data set is bigger, that's going to take a long time. Okay, so you can see the results like that on first epoch, second epoch, third epoch, and you can see the training loss is decreasing with epochs, and validation is also here. Okay, with validation loss, and then accuracy, you can see that it's increasing with the epochs and F1 score as well, precision as well, and recall as well. Okay. What I was doing, I was sending my logs to the website of the Hugging Face workspace during the training, and here you can see more graphs regarding the training. So what was happening actually per training? So you can see that this evaluation step per second. Okay, evaluation and recall was here. It was calculating the precision while training. Okay, and then again evaluation, runtime, and loss. So what this thing is that while you're training, each and everything, even a minor detail, it sends to that website, and it extracts that data. So the name of the website is wandb.ai. Okay, you can use that one for your detail checking of the training. Now that was the training. I just trained on 6 epochs. You can train if you're getting a good accuracy, just like I'm getting, which is 98, 99. This is enough for me. But you can train on like 6, 10 epochs. It depends on your experiment. Okay, so there is no fixed number for the epochs. Now after training, the next step is to evaluate the model on test data. First, we need to understand the training, that what happened during the training, how loss was decreasing with the passage of like time and epochs, and how it was affecting. So for that, I have the code here, where I'm extracting the log history from the trainer. Okay, I'm extracting the history. This history has everything. This history has loss, evaluation accuracy as well. So I'm saying for entry in log history, if the parameter is loss, give me the data regarding the loss and save it in this column. Okay. In the same way, I'm extracting the evaluation loss and evaluation accuracy. I'm saving the data and this variables. Now with graphs, I'm going to plot this one. So I'm defining the figure size, and I'm defining the subplot. So the meaning of subplot is here is that I'm saying that I want only one row but two columns. So this graph plot on to the number one. Okay, that should be a number one, and the rest of the things are same. You just give the epochs, training loss, and then label, which is training loss. Okay, I'm giving the training loss, and then again I'm giving epochs and evaluation loss. So it's gonna draw two things in within one graph. Okay, which is the training one. And I'm saying to the next subplot that this is the first row. That's fine. This, you just draw this graph to the second number, so that's gonna be on second number, and then yeah, in the second column. So this is the second one. So yeah, rest of the things are same. Epochs, evaluation, how you're gonna represent that, what color should be there. Okay, what should be the label there? You have to define it here, like the x-axis are the labels, accuracy, validation, accuracy per epochs. That's fine. And then in this way you can see that the graphs are here. Okay, so if I interpret this graph, how it is that these are the epochs from 1 to 6, and that's the loss. Okay, that's the loss. So in the starting, in the first epoch, the training loss was around 0.175. Okay, and the validation loss was 0.075. Okay, so the thing is that if the loss has to decrease. If it doesn't decrease and it increases, if it increases means that model is not performing good, model is not learning well. If it decreases with epoch, so it means the model is learning. Okay, we need as much as loss as we can get. But if you look at the other graph, which is between the epochs and accuracy of on the validation test data, so you can see that with the epochs, the accuracy of the model is increasing. So it's on first it was here, and the second it was here, on third it came back again, but in the fourth you can see that the model was learning, and it just went to the fourth, which is around 0.98, around that one. Okay, and it on this way. Okay, so it's mean that model is learning effectively. So you in this way you can interpret these graphs. Okay, I have the code here. You can save the model here. Okay, just uncommit that one, and you can save the model. You can again load the model here with the code. It's just pretty simple. You just need to give the path of the folder, and you can save it. I'm not going to save that one, so that's why I just commit this code. Now it's time to test the model on test data. We have seen the validation on validate data. Now we are going to test the model on 20% data set, which is unseen for the model. So model has never seen that data. Okay, so what we're gonna do is that, you know that our test data is in the form of raw at this moment. It's a raw data. It's just a English word. So what we're gonna do is that we have to convert the data in the form of numerical form, and specifically into that form which BERT model takes as an input. So tokenizer gives us the here I'm going to tokenizer. Inside that I'm giving text data. Tokenisation is okay. Padding is fine. That's fine. And I will get the encodings here. The encodings I have explained you above about IDs and attention mask. And then I'm going to give you this text encoding to my class, which I have explained you above, and it is going to give me IDs, attention marks with the labels as well. So then I will feed this text data to my model, okay, which is that at this moment trainer. Okay, so I'm uploading all those importing all those libraries which I need to evaluate the model, which is accuracy from sklearn matrices. I'm importing precision score, recall, F1 score, classification, and confusion matrix. So these are already built-in code. You just need to give the data inside these functions, and you're gonna get the results. Cbone is for the plotting, matplot is also for the plotting. We need to plot the that's why. The trainer, I'm giving the trainer, and it has a function dot predict. Inside that one I'm giving the test data set, and it gives me the test result, which is the labels the model has provided. Now what I'm going to do is that I'm going to extract the labels here with the prediction dot argument max x is equal to 1. I'm going to get the y predicted here. I have the true labels of those emails, so these are here. Now I'm going to give these two things, which is this is the prediction by the model, this one, and this is the true prediction which was in the data file here. So what I'm going to give is that I'm going to give this one to the my accuracy score to get the accuracy. Okay, I'm going to give the precision to give it to get the precision. In the same way recall, in the same way F1 score, and in the same way I'm going to give it the classification report to get the classification report. So if you go down, you can see all the matrices, text matrices you can see here, and this is pretty good actually. This is a 99% accuracy with the F1 scores and everything. You can evaluate them. Okay, and this is the on text test data, and the model has never ever seen this data. Now if we go to the confusion matrix, which is really important matrix to evaluate a model, so what we're going to do is that we again have a function, and we are giving this these two things again back to the, this is the true labels, this is the predicted one, to the confusion matrix, and we get the confusion matrix here. Now I'm going to plot the confusion matrix though, so I'm defining the figure size, which is the width and height for, and SNS is for the plotting, which is seaborne, and I'm saying heat map, and inside I'm giving the confusion matrix. Annotation is true, and the rest of the parameters are colors, and it's x-axis. You can give the x-axis, which you can define legitimate phishing, y-ticks legitimate. So it's talking about these things. So x-axis, y-axis, yes, it's talking about that one. X labels is the this the prediction, the below one, and this is the actual one, and that's the hiding there. And because the confusion matrix is between the actual labels and the predicted labels, so it tells that. So yes, so if you look at the confusion matrix, it's pretty good. The model is performing is really good. It has detected true positive this one and true negative 1500, like almost all of them. Just only few cases were there where it was unable to detect properly, because we got the accuracy around like 98%. If you train it more, you can increase it as well. Now let's go again to see the that's the another classification report you want. Okay, this report is also here on the top. You can see from here. That's fine. That's the same one. I'm just repeating here. If you just want to plot it separately, you can do it like that. Yes. One thing I need to tell you here is that where do we use the F1 score? So if our data set is imbalanced, there's a biasness between the labels. Okay, for classes, then accuracy doesn't work there. So you have to use the F1 score to evaluate your model. Yes. So that's everything from this project. If your model is really good, you got really good accuracy, you can save this model here with the help of this code, as I told you, and then you can use this model anywhere where you want to deploy it and use it. Either you want to use in network, anywhere you want to use it, you can use it in that model. If you want to load it again here and show unseen data to this model, you can also do that one. So that's the code here. Yeah, that's everything from this project. If you have any questions, any improvement you want in this code, or if you want any custom projects regarding your dissertation project or any project, you can contact me. I'll give you all the links below this video, video description, the data link, this GitHub link of this code, and yeah, everything. Feel free to write the comments about this project, okay, and share your feedbacks about that. And if you like this video, you can share with your friends so that they can learn from that, and it can be helpful for that. Thank you so much.